We're going to be continuing our look at the new features of C# 12, and specifically this week we're going to be looking at the idea of collection expressions. And once again, there's something that if you're a JavaScript programmer, you'll find are quite familiar, and in fact almost you may have been crying out for them in C# because they make certain things in C# rather quicker and more concise to write. So let's take a look at that. And what this is all about is the idea of how we do collection initialization. And we can look at the history of that, as it were. And to begin with, let's just put in the basic way that we can declare an array of ints. So we're going to say int array a1 equals new int, and then in this case on the right hand side you put a value inside those square brackets for the number of items that you want. So that's going to give us an array of 5 elements, and they're going to be initialized to 0 in the case of ints. If this were an array of reference type, they'll be initialized to null, whatever the default value for the particular type is. But we can also change that because we can put in some curly braces and actually give that whatever initial values we wanted. So just put in the numbers 1, 2, 3, 4 and 5, or whatever you might want to have, and that will then initialize it to those values. And we can see actually that the editor is already graying out some of that because now we've got some redundancy. The first bit of redundancy we have is we don't actually need to put the number in there at all, because it can infer from the fact we've given it 5 initial values that the size of the array must be 5. So that works perfectly well. But even then it's still graying out the new int square brackets bit, so we could actually go further than that, and if we made that a 3 we could just set it up like that, and that would give us the same initialization. So all three of those are doing the same thing, but obviously the third one is the most concise. One thing you couldn't do with this, however, you couldn't in that form just say var, because it can't work out what the type is meant to be. So that second one you could do a var on, that would work okay, which is why sometimes you need to put the new int square brackets, but we can see there are various ways of doing this. Now, something that particularly if you're programming JavaScript will strike you as a bit odd with this is the use of curly braces to initialize an array. Because in JavaScript you use square brackets to initialize an array, just like you use them to access an array, and curly braces are for object initialization. And even as a C# programmer, sometimes may strike you as a bit odd that we use curly braces here. It dates actually right back to the C programming language, and with slight variations this would be the same format, certainly those curly braces, how you would initialize an array in C. So that's why we have that nowadays in C#. And that's been there, as I say, since the beginning of C#. But what hasn't been there since the beginning is the ability to do this on collection types other than an array. So if we, say, had a list of ints, and we'll call that L1, and then we say equals new list of int, originally, when lists came in, which was in C# version 2, when generics came in, the way you'd then have to populate that, you'd have to say L1.add, and then put in a value 1, 2, and so forth. But it still worked fine, but it's quite a long-winded way of doing things. So in C# version 3, which came out with Visual Studio 2008, we have the ability to do the same sort of thing. So I can take those curly braces for initialization and I can pop them on the end of that list, and that will work perfectly well. Underneath the covers it's still doing exactly the same thing. It's doing the add, but we've got a more concise way of expressing that in the code itself. But one thing that we aren't able to do with that is what we have in that last version of the array form, where I could say list int and call this L2 and simply say equals 1, 2, 3, 4, 5. So that is not something that's allowed. It was only there on arrays, not on lists and on other collections as well. The most concise thing we could do, since the idea of fit and finish came in C# a few versions back, is we could just put in empty round brackets there, because it can infer that the type must be list of int from the fact we've got list of int on the left hand side. So that's a slightly neater way of doing it, but we can't do, as I say, the most concise version, where that would be a list of int that we just assign straight into. That is not going to work. So the key difference is when you're doing the curly braces with things other than an array, you've got to have the new and possibly the type in there as well. Again, depending on whether you're using var, this one you could have a var on, this one you wouldn't be able to have a var on because then it wouldn't know what the new thing you're creating was. But either way, you've still got to have at least that new to declare the object that you're then going to initialize. Now, having said all that, actually, I find that this sort of initialization of a collection to certain values is not something I do all that much in real code. It's very nice when you're doing demos of one kind or another, but data isn't something that you should really have in your program. It should come from a database or a file or wherever it may be. So hard coding values in there is a little bit unusual. It happens sometimes, but it's more a demo thing. But what you do very often is you'll want to generate an empty collection so that you can later populate it. Now you can do it with arrays. It's quite rare with arrays actually, because obviously arrays, once you have declared it, they can't have new elements put in there. But we can do that, and that would give us an empty array, just quite logical following what's going on in there. Other ways we could do it, we could say int array a5 equals, and then just new int, and then specifically say 0 in there. Or indeed, there's another way of doing it, int array a6, and then we could say array.empty int. So those all three do basically the same thing, though the first two are rather inefficient because they create a brand new array each time rather than what the third one does, which is just uses a shared empty array. But with arrays, not that common. When you're dealing with lists, it's much more common to want to do that. So we could say list int and then just call that one L4. Or indeed, again, with the fit and finish features, we could abbreviate that even further. So those would give us various different ways of declaring something as empty, and with a list that's quite nice because you can then populate it later on. So that's the old-fashioned way of doing things. All of those have been around for a while, but now let's look at the new feature in C# 12. And it's really simple. It just means that in array terms, we could say something like int array, call it a7, and then we could just say equals, and then in square brackets rather than round brackets, we could put in those initial values. So in terms of arrays, it's not giving us any real benefit. It's just using square brackets rather than round brackets, just the same as we had there. But even then, I think it has the slight advantage that it is a bit more logical. As I say, square brackets mean arrays, curly braces tend to mean objects, even though they can be used still in this circumstance. Of course, once again, what we can't do with that is use a var, so you have to have declared on the left-hand side what it is you're dealing with, so that one isn't going to work. But the really nice thing is that will now work with other collection types as well. So if I declare my list of int and call this one L6, I can simply on there say equals and then just put in one of these collection expressions, and that will now work fine. So I now don't have to put in any kind of new, anything like that. I can just say equals 1, 2, 3, 4, 5. And of course, under the covers, it's still doing the new, it's still creating the list, but it's just a much neater syntax, particularly if you're familiar with JavaScript, TypeScript, that sort of thing, where that's how it works. And particularly the benefit, as I say, is not when we are creating actual populated collections, because that's quite rare. It's the ability to create an empty collection, because now you can do exactly what you could do in JavaScript, and I find this just one of the neatest things in JavaScript compared with C#. I could just say L7 equals, and that's all I need to do to create an empty list. It's entirely logical, intuitive, in my opinion, that empty square brackets mean create me a new list. Probably because I've been programming JavaScript quite a long time as well, but I think even just to a C# programmer, that makes a lot of sense. So we can do that with any collection type, so equally with ints. If we do an int a8 equals, and then empty square brackets there again. And thanks to a little bit of trickery under the covers, that's doing exactly the same as the array.empty int, so it's using a shared empty array, not creating a new one, and so there's no performance issue there. So that's what we've got with our ability to do the initialization of arrays, lists, other collections in a very neat way. There is one slight limitation on the moment. It does not yet work with dictionaries. And that's something that, from what I hear, is going to be coming along in a later version, but not for now. So if we just look at how you initialize a dictionary, I could have done dictionary, and then let's have int and string, and then d1 equals new, all of that. And then the way we could initialize that is you can put in something like this. You can have the key, so item 1 equals, and then the value, which is a string. So put something in there, and then item 2, and so on and so forth. So that would fill out your dictionary. And so you might think, following the same logic that we've already seen, that we should be able to get rid of the new bit, change the curly braces to square brackets, and that should work. But it doesn't. As I say, maybe along in a subsequent version of C#, but it's not available at the moment. That said, there is still one thing you can do with this with dictionaries, and as I've already mentioned, what I think is the most important thing, you can use it to initialize an empty dictionary. So if we just wanted to say dictionary int string equals and then empty square brackets, that's fine. That's given us a new dictionary using the square brackets. So that's at least something, because having empty collections to start with is actually in real code much more common. Now there's another thing that's come in to C# that JavaScript programmers will recognize related to this, which is the spread operator. So let me just show you what that's all about. And so what we can do, suppose I was going to create a multi-dimensional array. So let's have a two-dimensional array, but I'm going to do this as the array of arrays form. So we'll look at the other form later on, but you can see that's an array of ints. And these things can get quite difficult to initialize. So let's just call that MA1 for multi-array 1. And what we can do now is we can do that using this format. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that one has now given me an array of 3 arrays, each of which has 3 values. They don't have to with these types of multidimensional arrays. There can be what's called jagged, where the different rows can have different lengths. But you can see that's a really neat way to initialize it that would be rather harder to do in the previous ways that we had. And you can even do that in a slightly more complicated way, because you could do something like this. You could, rather than having an array of arrays, you could have a list of arrays, and we could initialize that in exactly the same way. And that would have been much harder to do before this new feature, because you'd have had to have your new list or your new array or whatever in lots of different places. So really nice that because it knows what the type is on the left, it can infer and create all those objects that we want on the right. Sadly, this doesn't work with the true multi-dimensional array, where we can say int, and then to make it two-dimensional, we just put a comma in there. And so it might be nice if we could have taken those values, make a slight change, because a multi-dimensional array like this cannot be jagged, so it's got to go like that. But you can see that it's not liking that. And that's a bit disappointing, because the old syntax does work for that. So if I were to just go there and replace all of those square brackets with curly braces, then that's a perfectly valid way of initializing a multi-dimensional array. So again, I'm not sure if this one's going to be included later, but it seems a bit of a gap in what we have there that clearly structurally it makes sense. The compiler can understand it with curly braces, not quite sure why it's not there to be understood with square brackets, because it would just make everything so much more consistent. So that's just the idea of multidimensional arrays. But as I said, what that leads to is the idea of the spread operator. Because another thing I could do with multidimensional arrays, I could obviously take 3 existing arrays. So let's take the A1, A2, and A3 that we've already declared, and I could just put them in there, and that gives us, again, a multidimensional array with 3 rows, each of which has 5 items in there. But something you often want to do in this sort of situation is actually flatten those. So rather than having a multi-dimensional array with 3 by 5, we want to have all 15 elements in just a single dimensional array. And that's what we can do with this spread operator. So what we can do is simply say int, and now it's a single dimension array, and we can then take that initialization, but precede each one of the items with this spread operator ... Now, if you're a JavaScript programmer, you'll be familiar with the spread operator, which is 3 dots, but in C# they've gone for 2 dots. But that's going to give us basically this idea of just a single dimension array that in this case is going to have 15 items in there. And we could go further than that. We could, for example, then start putting in some other values on the end as well. So you can mix these things together however you like, and that will give us still just this single dimension array. And once again, that would work with lists and other things as well. So that's the new feature we've got with C#12 here. We've got the square brackets that can be used to initialize arrays and lists and other collections. We've got the empty square brackets, which can be used to initialize an empty collection, particularly on a dictionary, which doesn't yet have the other features. And also we've seen the spread operator. It's not as widely used as it is in JavaScript, where you'll see it's got all sorts of other uses as well, but the spread operator for flattening out an array is something that we have. But the question that I'm sure you're asking is, well, that's all very well for arrays and lists and so forth, but what about our own collections? What do we need to make that work? So let's start seeing how we fit this into our own collections. And so what I'm going to do is just add in here a new class, and we'll call this intList. So totally unnecessary to have this because all these features are available already in the .NET library, but it can just show us how things are working. So create our intList, and obviously now we could have a new one of those. So I could say intList and get hold of the namespace and call that intList and say equals new intList. But the first thing to notice about that is if I did int square brackets a10 equals, what I couldn't do is do a ... on intList. So that's not going to work because we haven't really done anything on intList at all. The bare minimum that you need to be able to do the ... on something is it has to be inumerable. So if we go back to intList, and we can start turning this into an enumerable. So we did a video on this a while back to how to implement inumerable various ways, and that's what I'm going to do here. And so all I'm going to do is give this a private field, which is going to be a list of ints. So it's not going to be anything very clever. We've got to initialize that, so we can immediately take advantage of that feature there. And then we can make this implement inumerable for int, get the editor to fill that in, and you can see it's given us the get enumerator so that it's now inumerable. We haven't got a way of adding any data as yet, but that doesn't matter. The point is that now we've done that, it accepts that it can be spread. So all that's going to happen when that spread operator has effect is it's going to enumerate through it and put each of the items into our array A10. So that's the first step, but also we'd probably like to be able to take our int list and initialize it using these new collection expressions. So I'd like to have an int list, and we'll call this int list 2, and then just say equals, and then just like we've done with everything else, put in those initial values. And again, you can see it's not accepting that. And in order to make this work, actually the rules are exactly the same as they were for making the older form, where we could do something like that work. This way of initializing a collection will only work on a collection that is both inumerable and has a method called add. And there's no interface required for the method called add, you've just got to have it there. So all I need to do is in here, we'll pop in a public void add, which has to take the type of the collection, which is int in this case, just call that val, and then simple enough here, we can just say list.addVal. And so now that we've got that, that means that back here, we can now do that kind of initialization. We'd also, with that, be allowed to do the slightly older form where we'd have to say new int list and then curly braces. So both of those work in the same way by calling the add multiple times to put all of that in there. So now we can use that with our own collections. There is a slight issue there though, because having an add may not be something you really want to have on a collection. What if we wanted to write some kind of immutable collection to which once you've created it, which is what we're doing here, you aren't allowed to add any new items? Well, that's the problem, because in order to make it creatable, we've had to give it the add. So there is another way of doing that. What we can do, let's create another class here. And this one I'm going to call Immutable int list. And I want to make this work without having an add. And so obviously it's got to be initializable. And the way we can do that, actually, let's do the thing we were looking at last time, which is the primary constructor. So if I on our class did something like this, I could have a params array of int and just call that values. And that now is going to, because that's a prime constructor, give us the field of values. And if we then make that inumerable for int, and then again we implement the interface, and again you can see it's clever enough that it will implement it through that values that we have in here. So that's a nice, neat way of doing it. We can't actually see the values field, but it's put one in there, as we saw last week with these primary constructors. And so now we've got a way of initializing this list. So now we could say something like immutable int list and call this IAL1 equals, do the new there, but we could pass in our values straight into that constructor, which is params constructor, so it takes as many or as few params as you like, and so we can initialize it that way, but we can't add anything subsequently. There is already a class for an immutable array actually inside the library, so we don't need to do this, but it's just showing what's happening. So that's all working pretty well, but the problem is, as we've said, this is not going to work with the square brackets form because we haven't given it an add, and we don't want to give it an add because that would mean it wasn't immutable. So there is another way of doing the initialization, which is this. We'll go back here, and we're going to add a new class here, but I think it's closely enough associated with the immutable int list that it should go in the same file. But what we're going to do is pop in a new class that I'm going to make a static class, and I'm going to call this immutable int list builder. You can call it what you like, but that's the convention that's commonly used. And then in this immutable int list builder, I'm going to put a method which is going to be public, static, and it's going to return the type that we're trying to create, the immutable int list, and then it's going to be called, and again, you can actually call it what you like, but create is a pretty common one, so that's what we've got there. And this create has to take those initial values, so the 1, 2, 3, 4, 5 we have there. What is the actual type it's going to take, though? You might think it could take an array or something like that. What it actually takes is a read-only span. Now, I did a video on spans quite a while back, but basically that's what we're going to have. So the reason it's done as a span is to save doing an extra copy, so it doesn't have to copy these values into an array and then copy them into my collection. It will just happen all in one go. So now all I need to do is on here, I can say return new immutable int list and then pass in there values dot, and I've got to do a dot to array there. So that's where we've got the one copy, but we've avoided a second copy. So we've got this builder, and now last thing we have to do is associate the builder with the actual list that it builds. And so on here, we've got to put an attribute, and that attribute is called CollectionBuilder, and it takes the type of the builder. So we've got to put in type of, and then that's the builder there. So that's saying when we create an immutable int list, use the immutable int list builder, and then the second parameter has to be the name of the method, in our case create, that's going to do the work. So we can have name of, and then just put that in there. So much better to use name of to avoid the risk of misspelling and that sort of thing. So that's associated the builder with the collection, and now we can see if we put that in there, that's working fine. So that's the alternative way, if you don't want to have an add, of making it so that you can use these collection expressions. And so now we've got that, we could loop through those, we could do something like a for each loop, and change that to ii2, and then just print out the value, and nothing special. If we run that, then we're getting 1, 2, 3, 4, 5. One question you may be asking, what happens if we have both? So let's go to our immutable int list and just put in here an add. So public void add int value. I'm not going to actually get it to do anything because I can't really, because this is immutable because of the way we created it, but it now has both of them. And let's just put a breakpoint on the add and on the create and see which one is now going to get called. So if we run that up in the debugger, and we can see that it's the create that takes priority there. So that's how that was being done. So even though we've got an add, it's going to be ignored. Why would you want to have both? Well, maybe you've got a highly performant way of doing the initialization, which is much better than doing the repeated adds. So that's why it takes precedence and that will work most efficiently. So that's it really. That was our idea of collection expressions, a really neat way to initialize almost every type of collection. Bit of a problem with dictionaries still, but certainly very useful, very neat just for initializing empty ones, which is I think going to be the biggest use of it for the reasons I said. But also we saw the spread operator, and also we saw how we can get this working with our own collection classes, even though that's again quite a rare thing that you're probably going to want to do. So we've still got more C# 12 to look at, but I hope you enjoyed that. If you did, do click like, do subscribe, and I'll see you next time.